Hi, welcome to our math. Today we're doing a series of videos on exponential functions. In this one, let's see, it says the bacterium that can cause strep throat has a doubling time of 20 minutes. In the presence of a certain antibiotic, the doubling time is 4 hours, which is way better. The cultures are prepared and the antibiotic is added to one of the cultures. Initially, the culture has 100 bacteria. All right, it says find an exponential model in each culture after T hours. So this is kind of interesting. For the first one, we want to get it to an hour, but we're told that the doubling time is 20 minutes. So 20 minutes, 40 minutes, 60 minutes. It'll double 3 times in an hour. So it'll double here, it'll double here, and it'll double here. And remember, exponential means we're multiplying. Doubling means to multiply by 2, which means A is double once, double twice, double 3 times. In other words, A in this case is equal to 8. So for our first situation, we have bacteria over time, B of T, is equal to 100 bacteria times 8 to the T. Okay, nice. For the second one, it says in the presence of a certain antibiotic, the doubling time is 4 hours. So here we have 4 hours, and we want to get down to 1 hour. So if we look at this, the doubling time is 4 hours. So this is 2. What we really want is we want 1/4 of that time. When we wanted 3 times, our exponent became 3, 2 cubed. If we want 1/4 of it, we say A equals 2 to the 1/4, which is going to equal 1.189, about, rounded. So in this case, the bacterial growth is 100 times 1.189 to the T. Okay. It says graph the models for T between 0 and 8. So for the first one, let's say B of T equals 100 times 8 to the T. When T is 0, we have 100. When T is 1, we have 800. When T is 2, we have 6,400, which is already off our graph because our graph here is bacteria. And here is hours. And it takes, for this one, we have 0, 100, then 1 is 800, and 2 is 6,400. Whoa! It's a crazy graph. Okay, so we really don't need more than that. For our second one, where we have B of T is equal to 100 times 1.189 to the T, let's see if this one gets insane. We start with 100. After 1 hour, we're at 118.9. After 2 hours, we're at 141.37. After 3 hours, we're at 168.1. I think I see what's going on here. Let's see. If we go to 5 hours, we're at 237.6. If we jump all the way up to the 8 hours, we have doubled twice. It has doubling of 4 hours. 4, it should be 200. At 8, it is 400 because we've doubled twice. So we start at 100. Then 1 is, 118. Let's see, 1, 2, 3, 4, 5. So each of these is 40. So less than 140, more than 140, 160. 5 is 237, 8 is 400. Here is our exponential growth of this one. All right. It says, what do you notice? What do the graphs tell us about the number of bacteria? They grow much slower in the presence of an antibiotic. For each model, find the predicted number of bacteria after 8 hours and after 12 hours, round to the nearest whole number. Okay, so for the first one, we have B of 8 equals 100 times 8 to the 8, which is going to be 16777 So 1.68 billion, and after 12 hours, which is 100 times 8 to the 12, we get 6.87 times 10 to the 12. It's just a huge number. Huge number of bacteria. For our second one, B of 8 equals 100 times 1.189 to the 8, which we've already calculated out to be 400. I should, for all of these bacteria, should always label these. B of 12 is 100 times 1.189 to the 12. And this is going to be 800 bacteria. So the funny thing is, it takes 12 hours with the antibiotic to get what we got in 1 hour without it. So there is why it is good to have the antibiotic. All right, I hope you have enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.